We do this test portion today. Class 10 Math 6.3D, exercise 6.3, go to page 146, okay, there. Start with B6. Let me read the question for us here. In the figure, so let us draw the figure that is given to us. Looks something like this, so let us draw it by looking into the text. A, B and C. Here is marked D, E, and BE is joined. Sorry. BE is joined and DC is joined. Like that is given to us. So let us write the given here. Given to us is in the figure here, triangle A, B, E is congruent, okay, congruent, means same in shape and size. Triangle ACD, these two are congruent. We need to prove here, triangle ADE is similar to triangle ABC. Start the proof, means the answer for this proof. Since we are given here triangle ABE congruent to triangle ACD, because this is given in the question like that for us, okay. Now we learn in class 9 also that if two triangles are congruent, then the corresponding sides are equal and the corresponding angles are also equal. We need the sides, so let us just take here. Therefore, the first two letters AB. Then what are the first two letters in the next triangle? That's right, SC. So this first two letters making one side of the triangle ABE, and the first two letters SCE in ACD, they are the first position letters that make the sides here, the same position letters, first, second. They are called corresponding sides, and we know that corresponding parts here mean the sides of the triangle as well as the angles, the three angles. So CP, CT, we are allowed to write like that in short forms. Corresponding parts of congruent triangles are equal, right? So CP, CT. So that will give us here AB, and then we know that any number given to us, whether AC or 2 or whatever, can multiply by 1. So if you want, you can put your 1 and shift this, then it will come down. So let us put this one as equation 1. Okay, without thinking too much. Now next here, let's take the first and the third letter, because that constitutes the side of this triangle here, AE. So I'm taking here AE, and first and third means here also first and third. That is called corresponding sides. Again, do means CPCT. So now this time, let us write here into 1. Anything can be multiplied by 1. So here, that gives you 1 is equal to, I like to do like this because they have given in this order. Sorry, ADE. ADE similar to triangle ABC. They are going like this, ADE, ABC. So that's why I'm arranging it to conform to this form. Okay, so AD by down here, EE. So you can shift this down. Now next step, that implies now 1 and here 1 same, means you can replace this 1, 1, this 1, 1. So 1 equal to this. So we can replace this 1 by this one. AB by SC is equal to, so this 1 here has been replaced by this AB by SC equal to this same one AD by AE, and you can write here since using equation number 1. So you can keep this one as equation number 2. Then let us do it like this, just to make it simpler for us. Cross multiply up and down, then after that equal, then up and down or down and up, SC into AD, like that we can write. Now they're mentioning here a small triangle first, so maybe we can write here AE, side of the small triangle, ADE is the side AE, then the big one here, AD is the side of the small triangle, so take the big one down here. Then this has gone here, then this is same side, so AD by this will go that side, so it will come down, going that side, coming down, this one coming this side, coming down, on the same side, on the same side. So let us keep this one as equation number, this one not to, just remove it, this one is equation number 2. Let's do one thing, find the angle between these two sides here, this and this, AE and AD. So between AE and AD is this angle, angle A. Between these two sides, AC, AB also the same angle. They are equal because it's the same angle, means we say they are common. This angle is common to both the sides, both the triangles. So you can put this one as equation number 3 following 2. Now here using equations 2 and 3, observe carefully that in this triangle here ADE, these two here AE by AC of the big triangle, right, and then AD is similar to, okay, so AE and AC, then AD of the small triangle, AB of the big triangle. So two sides here, two sides of this triangle ADE, and these two sides of the triangle big one ABC are proportional because the ratios are equal, means proportional, and the angles between them, these two, and angle between them are equal, means we know from our previous chapter, from this chapter, that there are 4 similarity conditions: AAA, AA, SSS, and then one more, SAS. So by this condition, two sides proportional and angle between them, the angle must be between, and we saw that it's between AE and AD is A, SC and AB between equal, then the triangles are similar, so triangle. Now the order AE here, see, AE, then going this side AD, AE, AD. So we can, since they're mentioning ADE, maybe we can go this direction, AD and AE. So AD, then AE. Then this also has to go this direction. Because in writing similar triangles, the position of the 3 letters of the triangle should be corresponding. Means we cannot just simply write like that. So if you go in this direction, right to left, AD first, AE second, AD first, AE second, means ADE. That because that's how the question has arranged for us here. We want to follow this, right? So if you go from right to left here also for big triangle, also you have to go left to right. So AB, SC. So AB first and SC second, means ABC. So this is correct now, and we know because of using SAS, similarity condition or criteria, right? Criterion. So this is proved now. AD is similar to triangle ABC. So that ends are proving. Now let's go to B7, the next one. B7, let me read the question for us. In this figure, so let's just draw the figure first. Figure is something like this. A line, oh sorry, I think we need to draw a little bit in that opposite fashion, like this, right, like this rather. So a line is drawn perpendicular 90 degree here, I think. Yes, and then here also another line drawn perpendicular 90 degree here. The letters here are C, D, B, E, the intersection point here P, A. So given, as we see the question in the figure here, altitudes AD and CE of triangle ABC, big one, A, B, C. Altitude means the perpendiculars, okay? Heights intersect each other at the point P. So this is given, and we have to show means to prove only. To prove, number one, triangle AEP similar to triangle CDP. Second one, triangle ABD similar to triangle CBE. The third one, triangle AEP similar to AEP similar to triangle ADB. And the fourth one here, we have to prove triangle PDC similar to triangle. So these four things we have to prove. Let us start the proof one by one. Here, let us take the first one, number one. So look at these two triangles, AEP, AEP, this one, and CDP, CDP. So these two here, let me just write this one 1 and this one 2. So A, nothing seems to, so E. So let's write here first angle AEP. See here 90 degree. Perpendicular means this is AEP will be 90 degree. Then AEP, then E is the vertex, middle point. Middle is, yes, D is also perpendicular. So CDP, angle CDP. Because this is 90 degree, and you can write here since each being 90 degrees. So you can keep this one as equation number 1. Then let us find out in these two triangles AEP, one angle is already equal. 1 here in AEP will be equal to 2 here in CDP, because we know this is very simple since there are vertically opposite angles. So this is 2, let us say. So let us say here, using equations 1 and 2, we see that in these two triangles, okay, 2 angles of this triangle are equal to 2 angles of CDP triangle. So if 2 angles are equal, in 2 angles of 2 triangles are equal, then we know that the 2 triangles can be similar, because the similarity condition are AAA, AA, SSS, and SAS. So it is obeying this one. two angle criteria. So they're writing A first, which has no reference to the angle here. So A, no information. Here 2 and 1, D is here, E is here. So the one having no information is C. So if you start with A, the other triangle that us start here also should start with C, because first position, second, you need to get it exactly correct in writing similar triangles, otherwise it's wrong. Okay, so A, then if you go here, then you need to go here, because this is the angle equal to D, E equal to D, so second position should be D. And 1 is the point P for AEP, so P similar to, then 2 is the point, there P is for CDP, the third letter point will be P. So you can see these two are similar, and we can write here since using AA similarity condition. So this is proof first one. Let's go to 2, that is number 2 here, ABD CBE. A, B, D, let us trace once, and CBE, C, B, E. Are they similar? We're going to check. So CBE. So both of them seem to have A, B, D, C, B, E. So B is common. So maybe we can start with that one. Angle B equal to angle B. Angle B inside ABD equal to angle B inside CBE, because they are common angles, common to both the triangle. So you can put this one as equation number 3 following 2. Then in this triangle, find the perpendicular point, because there is one, I think, A, B, D means this one. So ADB is the one. Angle ADB. The point D is the 90-degree point. And then in the CBE, E is the one. So you can write your angle CEB, since each being 90 degrees each. 90 degrees. So we may put this one as equation number 4. So like we have done in the first case, two angles we see now of this first triangle ABD equal to these two angles inside this triangle CBE. So if two angles are equal, then the triangles are similar by AA. So therefore triangle. Now we're starting with A, which has no information given here. Information about the angles vertex are B and D, but A is not given, so we start with A means B and E is given. B and E, but C is not given, so we have to start with that one's C. Then if you go B here, then here also B. And third point is middle point D, here middle point E. That is called writing in proper corresponding points. Okay, this is very important in similar triangles. If you get the order wrong, ABD, and you write here CEB, all the marks will get cancelled because that's wrong. Okay, so write your since using AA similarity condition. So this is second one proved. Let's go to the third one. The third one is here. We have to prove AEP ADB. Let's trace once. AEP ADB, this triangle. AEP, this small one, and ADB. So in these two triangles, AEP and AD, so common is A, so we can start with the A inside the first triangle AEP equal to A inside ADB, because they are common angles. So you can put this one as 5 following the last one 4. Then find the 90-degree point. E is the one, so angle AEP inside this triangle AEP equal to angle ADB or not, check. See here. Yes, D is the 90-degree point. So they are equal because each being 90 degrees. So we can write this one as equation number 6. Therefore, two angles of the triangle AEP equal to two angles inside. These two angles inside ADB. So the triangles will be similar by double A again. So triangle, they have written here A first. So here A. So for the bigger one also A, the other one. Then they have written E second, like this exact middle point E. Here middle letter is D, so here also D. Left is P, so just write P, and left is B. Now it's matching C, ADB, AEP. They will be similar because using, again, double A, similarity criterion. Finally, the last one, the fourth point. So here, you can write here, using equations 5 and 6, we are getting this, okay? Now the fourth point, let us write down here PDC and BEC. PDC and BEC. BEC, okay. PDC, so PDC and BEC, so BEC. PDC, okay, PDC. So C is common in both PD. Okay, let us write this one. Angle PDC, 90 degree. And here BEC. BEC. Perpendicular point is the E point in triangle BEC and D point in the triangle PDC. You can write here since each being 90 degrees each. Equation number 7. Then find out PDC and then BEC. BEC. So C is common. So angle C inside this triangle, PDC, equal to angle C, third letter. They are equal because this is common angle. So let us write this one as equation number 8. We're using equations 7 and 8. We're going to get here these two triangles P. There is no information about the angle P. In the PDC, we didn't take P, only D and C. So we start with P means here also we start with what is not given. P is not given. Then E and C. E and C information is there in BEC. So BEC. So B is not given. So we start with B. Here P at the vertex P, the angle information is not given here. So we'll start with that, like we are starting with the question in the way the question is doing. Then next is D. And so this is the middle point D. And here the middle point is E. Here C, third. Here C. These two will be so PDC similar to BEC. We're correct now because again double A similarity condition. Two angles inside this triangle equal to two angles in the other. So the triangle will be similar by double A criterion. B7, okay, that is. Now let us go to the next one, B8. Okay, so B8. So here, B8 is, let me read the question for us. Okay, so maybe we can continue the next two questions in the next class. Okay, so we've done 6 and 7 here, 7, 8 and 9 in the next class.